This video shows different applications of our sampling-based scene space video processing method. By exploiting redundant information collected over many frames of video, our general purpose approach can be used for a wide range of applications. Let's start with video denoising. This scene consists of moving objects and is filmed with a handheld camera. This is the result from an existing state-of-the-art video denoising method, spatiotemporal BM3D. Our simple, transparent scene space filtering approach achieves similar quality results. This is the depth map used to denoise this scene. One of the main advantages of our work is that while it operates in scene space, it is robust to the unavoidable inaccuracies of 3D depth and camera pose estimation. Here we show one more result with flickering, color-changing LED illumination. Our approach can successfully remove the flickering and recover from blocky compression artifacts. We can even obtain reasonable results for this especially noisy scene. We can also use our method to remove rain from video. Similarly, our method can deblur frames from handheld footage. Notice how the pay here sign becomes clearly readable in this deblurred frame. We again obtain similar results to a state-of-the-art patch-based video deblurring method. Here we perform super resolution, increasing detail on the globe. We can also use our method for video inpainting. Here is an example image and depth map used by our approach and a subset of the frames projected into scene space. The large number of outliers is clearly visible in this point cloud. We can specify objects to remove entirely in scene space as shown here, which projects into the video as this red mask. Finally, we can render an object transparent, or remove it entirely. Here we compare it to an existing state-of-the-art video inpainting method. As input, this method takes a 2D mask. Here is their result. And here is ours. You can see that the occluded scene structure is preserved by our approach. We can additionally create interesting computational shutter effects. Given this handheld input video, here we show a virtual aperture video with a shallow depth of field. And here you can see a synthetic focus pull from back to front. This is a scene space long exposure, where the moving water is blurred but the background remains sharp. An image space long exposure, on the other hand, shows large amounts of blur due to the camera movement. In this example, the river is blurred on the right. This is most visible in the rocky area in the center. We can also create scene space consistent action shots like this, where despite some artifacts from incorrect depth, the frozen character displays correct occlusion and parallax as the camera moves. Thanks for watching.